So today I'm going to tell you about Pollen. Um, Pollen is a secure, decentralized messaging service designed to be used primarily when a government renders the internet unusable. So messages propagate in the same way that bees pollinate flowers, and I'll give an example scenario to better explain that in a second. But some benefits are there's no minimum user or node requirement, unlike mesh networks, which are sometimes used in similar scenarios. Pollen could function with only 2 users and works even better with more. Messages are encrypted before they leave users' devices using PGP, which is a well-vetted encryption protocol. You don't need to worry about me writing my own. And it's completely cross-platform. Everything's written in Python. The GUI, which is unfortunately not done yet, is built with Kiwi, or Kiwi, I'm not sure how you pronounce that. But yeah, I can build releases for practically anything, and as is, Python can run anywhere, anyway. All right, now I'm going to give you an example scenario where I think shows some of Pollen's positive features. In this scenario, there are 3 users and 2 nodes. For some background, user 1 has messages for user 2 and user 3, but can only connect to node 1. User 2 has a message for user 1 and has the ability to connect to either node 1 or node 2. And user 3 has a message for user 2, but and can only connect to node 2. So you can see right off the bat there's no direct link between user 1 and user 3 who want to exchange messages. So in this case, user 2 is going to transport that message. It's not an opt-out thing, or it's not an opt-in thing, rather. Anytime a user connects to a node and leaves messages for others, or picks up messages for itself, it takes a certain amount of messages for other users to propagate to other nodes, and that's actually based on the amount that they're using the network themselves. So if they're sending and receiving a lot of messages, they will be distributing a lot of people's messages. So, okay, so first, in this case, user 1 connects to node 1, and they deliver their message for user 2, they leave that there, and they also deliver their message for user 3, and they leave that there, and they disconnect. And this is all, none of that's manual, and once they connect, that's all done automatically. And then user 2 connects to node 1. They deliver the message they had written for user 1, and they receive the message for that user 1 sent them, and they also receive, still encrypted, the message for user 3 from user 1, and they disconnect from node 1. Next, user 2 connects to node 2, and though there aren't any messages for them there, either to be picked up or dropped off. And actually, what's important to mention that I don't specify here is each message by default is set to deliver to a certain number of nodes from the original user, and also from the other users propagating them. So in this case, this is actually incorrect, and I'll correct it in the uploaded version, but user 2 would not just leave their message for user 1 at node 1, because there's no way of knowing that that user 1 has access to node 1. So it would also be left at node 2 and any subsequent nodes user 2 connected to. So anyway, user 2 connects to node 2 and delivers their message for user 3 and also delivers their message for user 1. And they disconnect. Next, user 3 connects to node 2 and they deliver their message for user 2, but they also receive the message that was originally from user 1 but was transported to node 2 by user 2, and they disconnect. And that's the basic concept of how message propagation works. It's effectively like a dead drop. It's an asynchronous exchange. Yeah. All right, so now I'm going to go ahead and show you that scenario that I just described. You should follow along with the script if that makes you feel more comfortable. And feel free to look through the code. All the methods are properly written out. So I'm going to start node 1, start node 2, and then I'm going to run user 1. And user 1 just connected to node 1 and dropped off 2 messages there. And also, if you notice, created 2 new conversations with 2 unique contexts. Next up, user 2. User 2 just connected to node 1. They connected to node 1, dropped off 1 message, picked up 2, and then connected to node 2 and dropped off 3 messages. There's a little bit of overlap there for messages that already existed in memory, and also while it's trivial, duplicates are not actually currently being filtered out, to be completely honest. But I got to get this video in. Next up, user 3. So user 3, as we talked about before, just connected to node 2, dropped off 1 message, and picked up 3. And now user 3 has access to user 1's message, among other things.